This is Lesson 2, which covers exponents and scientific notation. We will start by talking about exponents. As you know, an exponent is written as 2 with a superscript number. Now, in my example here, I have 2 to the third power. That's simply equal to 2 times 2 times 2, or 8. So that's typically the way we write an exponent. But now let's look at properties of exponents. Let's start with the negative exponent rule. Whenever you have a negative exponent, for example, b to the minus n is the exponent, that is equal to 1 over b to the positive n. So if I had 5 to the negative 3, that would be equal to 1 over 5 to the positive 3, or 1 over 125. Next, we have the zero exponent rule. Whenever you have any number raised to the 0 power, that's equal to 1. It doesn't matter whether it's a positive or a negative number. Any number raised to the 0 power is equal to 1. We next have the product rule. If we have a number raised to the m exponent multiplied by the same number raised to the n exponent, it's equal to b to the m plus n, okay? So now let's look at an example. Say I've got 2 raised to the 2 times 2 raised to the 3. That's equal to 2 raised to the 2 plus 3, or 2 to the 5th, or simply 32. Now we have the power rule. Say we have a number b raised to the m power, and that whole thing is raised to the n power. Well, then that's simply equal to b to the m times n. So let's look at an example here. Say I have 2 raised to the 2, and that whole thing is raised to the 3. Well, that is simply equal to 2 to the 2 times 3, or 2 to the 6th, or, in this case, 64. Notice the difference between this example and the previous example, okay? When you have 2 to the 2 times 2 to the third, as opposed to 2 to the 2 raised to the third. In one case, you add the exponents. In the other case, you multiply the exponents. We now have the quotient rule. Say I've got b raised to the m divided by b raised to the n. In this case, we subtract the exponents, and it becomes b to the m minus n. So if we had an example like this, where we have 2 to the 8 divided by 2 to the 5th, that would be equal to 2 to the 8 minus 5, or 2 to the third, or simply 8. So now let's look at the last two properties of exponents. These last two relate to products raised to powers and quotients raised to powers. The first of these will be products raised to powers. For example, if I have a product a times b, and I raise that to the nth power, it's simply equal to a to the n, b to the n. So let's look at an example. Let's say I've got minus 2y in parentheses raised to the 4th power. That would be equal to minus 2 raised to the 4th power times y raised to the 4th power, or simply positive 16y to the 4th. Now let's look at a quotient raised to a power. Say I've got a over b raised to the n. That simply is equal to a to the n over b to the n. So now let's look at an example. Let's say I've got, in parentheses, minus 3 over x, and that whole thing is raised to the 3rd power. Well, that becomes equal to minus 3 raised to the 3rd power over x raised to the 3rd power. Or, completing that, would be minus 27 over x raised to the 3rd power. So now let's look at some examples of how we can use these properties to simplify exponential expressions. So let's start with this expression. In parentheses, I've got minus 3x to the 4th, y to the 5th, and I want to raise that whole thing to the 3rd power. So how do we go about doing that? First, we start by breaking the expression in the parentheses up and raising each part of those to the third power. So in other words, we've got minus 3 raised to the third, x to the fourth raised to the third, and y to the fifth raised to the third. So we take each of these. So minus 3 raised to the third is simply minus 3 times minus 3 times minus 3, or minus 27. X to the fourth raised to the third. Now remember that property. In this case, we multiply the exponents. So it's 4 times 3, or x to the 12th. And similarly, when I got y to the fifth raised to the third, again, I multiply the exponents 5 times 3, and I get y to the 15th. So here's an example, one example of simplifying an exponential expression. Now let's look at another one. Now in this case, I've got in parentheses minus 7x y to the fourth times, in parentheses, minus 2x to the fifth y to the sixth. Okay, so basically what I'm going to do is multiply the like terms, and the coefficients, the x's, and the y's. So now I've got minus 7 times minus 2, x times x to the fifth, y to the fourth times y to the sixth. Now, the minus 7 times minus 2 is going to be basically the way you multiply numbers. Negative times a negative is going to be a positive. But let's see what happens when we multiply the variables to the exponents. So our final answer becomes, as I said, the minus 7 times minus 2 is plus 14. X times x to the fifth, we add the exponents. X, the exponent is 1. X to the fifth, it's 5. So 1 plus 5 is 6. Y to the fourth, y to the sixth, we add the exponents. 4 plus 6 is 10. So our final answer is 14, x to the sixth, y to the 10th. So let's look at another example. Let's say I've got in parentheses minus 35 x squared y to the fourth, that whole thing divided by 5x to the sixth, y to the minus 8. Again, we're going to take the like terms and we're going to perform the division. So now we have minus 35 over 5 times x squared over x to the sixth times y to the fourth over y to the minus 8. The minus 35 over 5, this is a simple division problem. We're going to come up with minus 7 for that. Now notice the exponents. We're going to have to subtract the exponents. Be careful now, whenever you got that minus 8, it's going to be minus a minus 8. And let's see what our answer comes out to be. We now have minus 7, x to the minus 4, because it's 2 minus 6 is minus 4, y to the 12th, which is 4 minus a minus 8. Now, one thing we notice about this is I've got a negative exponent. Negative exponents are considered to be non-standard. So how do I make that a positive exponent? So in order to make that minus 4 a positive exponent, we simply take the x to the minus 4 and put it in the denominator. And now our final answer reads minus 7 y to the 12th, the whole thing over x to the positive 4. So our last example of simplifying exponential expressions will be the quantity 4x squared over y, that whole thing raised to the minus 3. Now, there's a couple different ways we could do this. We could simply raise every part inside the parentheses to the minus 3 power. But notice, we are raising to the negative 3. Therefore, my preference is to change that to become positive. And how do we do that? We simply get the reciprocal of what's in the parentheses and raise it to the positive 3. So now basically I'm going to flip everything inside the parentheses. So I've got y over 4x squared. And now I'm changing the exponent on the outside of the parentheses from minus 3 to positive 3. And now we can continue with positive exponents. So now we have y to the third over 4 to the third times x squared to the third, okay? So let's see what we end up with for our final answer. And lastly, we finally have y to the third over 64x to the sixth. Again, notice we multiplied the exponents of x, so it was x squared to the third, so it's 3 times 2 or 6, okay? So now let's talk about scientific notation. Scientific notation is simply a way of writing very large or very small numbers in a concise, simple manner, rather than having a lot of zeros. Let me give you an example. The distance from the Earth to the Sun is 93 million miles. Now, we could write 93 million as 93 followed by 6 zeros, or we could use scientific notation. So in scientific notation, the distance from the Earth to the Sun could be written as 9.3 times 10 to the 7th, okay? So we don't have to write all those zeros. And if we look at it, basically we're saying multiply by 10 to the 7th, which is 10 million. So multiply 9.3 times 10 million and you'll get 93 million, okay? So this is one way of using scientific notation. Now let's say we have a very, very small number. For example, 0.00000064. How could I write that in scientific notation? That could be written as 6.4 times 10 to the minus 7. Okay, please note that in either case, whether we're talking a very large number or a very small number, the first number is a number between 1, it's greater than 1, greater than or equal to 1, and less than 10, okay? So we might have a certain number of significant digits, but basically the initial number here is a number greater than or equal to 1 and less than 10. And then it is multiplied by 10 raised to the exponent, okay? So this is how we write scientific notation. You can now proceed to the worksheet on this lesson and try some examples and see how you do.